notes for lesson 1.7, solving absolute value equations and inequalities. So we've looked at how to solve equations, we've looked at how to solve inequalities. Now we're going to add an absolute value, and we're going to talk more about absolute value and their graphs later on. But we first want to look at their equations and how they apply in different situations and equations. So just a reminder, the absolute value is the distance of a number from 0 on a number line. It is always non-negative. So again, the distance from 0, it's always going to be a positive number. So for number 1, the absolute value of x equals 3. So x could be either a positive 3 or a negative 3, because again, the absolute value always creates a non-negative number. If we have the absolute value of x, we could have x if x is positive. We could have 0 if x equals 0. And it could be negative x if x is negative. So again, there are multiple different solutions inside the absolute value. So for number 2, if we are solving the absolute value of x minus 3 equals 5, there's two different ways that we can solve these. The first option is the one that I prefer. I think it makes the most sense, but the second option is always available as well. So what we are doing is if we look inside the absolute value, we know that it can equal 5, or what's inside the absolute value could be negative 5. Since it's the absolute value, it will still give us a positive solution. So we need to set up two different equations. X minus 3 equals a positive 5. And again, if it's a negative 5 inside the absolute value, that will still give us the positive 5 solution. So we also need to look at x minus 3 equals negative 5. And we're going to solve both of these equations to find our solution. So again, for the equations to solve, we need to add 3 to both sides. So x equals 8. And again, we're adding 3 in both equations. And x equals negative 2. So x is either 8 or negative 2. You can plug those in and double check to make sure that the solution is correct. Now the other option, again, whatever's inside the absolute value could either be positive or negative. So again, x minus 3 equals 5 is one solution. The other solution is if x minus 3 is negative. So a negative x minus 3 equals 5. So again, we solved this equation before, so we get x equals 8. To solve this other equation, we first want to distribute our negatives. So we have a negative x plus 3 equals 5. We're going to subtract 3 from both sides, so negative x equals 2. And to get a positive x, 2 has to be negative. So again, x equals negative 2 or x equals 8. So again, it's just two different options, two different ways of solving the same equation. And you always want to check your solutions, make sure that they work, because in some cases they might not all work. Example 3, we're solving the absolute value of x plus 2 minus 18 equals negative 12. So the first thing we need to do is get rid of anything that is around the absolute value. So the first thing you want to do is add 18 to both sides. That gets us the absolute value of 10x plus 2 is equal to 6. So then from here we want to set up our two equations. Again, whatever's in the absolute value can either be positive or negative, because the absolute value then makes it positive. So 10x plus 2 can equal a positive 6, or 10x plus 2 equals a negative 6. And that's our two cases that we need to look at. So to solve, we want to subtract 2 from both sides. So we get 10x equals 4. And we're going to do the same steps on the other side as well, so we might as well just do those together. So 10x equals negative 8. And then we divide everything by 10 for our final step. So x equals 4/10, which simplifies to 2/5. Or x equals negative 8/10, which is the same as negative 4/5. Again, if we plug those back in, both numbers will work. Our next example, again solving the absolute value of 10 minus 3x plus 5 equals 2. Again, we want to get rid of everything that is outside of the absolute value first. So we're going to subtract 5 from both sides. So we still have the absolute value of 10 minus 3x equals a negative 3. I want you to look at this one for a second. The absolute value of some number or some expression is going to equal a negative 3. We said before, anything that's the absolute value is always going to be a positive solution. So in this case, there's not going to be anything in this absolute value that will get us a negative solution. So this is a special case where we have no solutions. So again, it's really important that we look at our solutions, we look at our problems, and make sure that they make sense. We also want to recall that in inequalities, if you do multiply or divide by a negative number, you must reverse the inequality sign. So on the next page of notes, we're going to start looking at inequalities. We're going to be solving them the same way that we did equations with the two different cases. Our next example, we're looking at absolute value and inequalities. As I said before, you're going to solve this the same way that you did before. So absolute value means that we are going to look at both cases. So there's two different options for solving. The first is 6x minus 3 is less than or equal to 15. The second case is going to be negative. Whenever we divide or multiply by a negative number, we have to switch the sign. So the second case, 6x minus 3, is greater than or equal to negative 15. So if we change the sign, we have to change the symbol as well. And then again, we just solve like we did before. So we're going to add 3 to both sides. 6x is less than or equal to 18. Divide by 6. X is less than or equal to 3. And then our second case, same steps as before. So 6x is greater than or equal to negative 12. Divide by 6. X is greater than or equal to negative 2. Now, if we start out with less than or equal to, this is going to be an and inequality. So we want to make sure that we watch for that when we look at our solution. So we're going to put negative 2 on our number line. It is a closed circle because it's or equal to. We need 3 on our number line, again closed circle. We have greater than or equal to negative 2, so we're going to the right. We have less than or equal to 3, so we're going to the left. If it's an and, again our solutions need to satisfy both. So from negative 2 to 3 is our solution. Or x is less than or equal to 3 and x is greater than or equal to negative 2. Now the other way we can look at this, just like we did before with our equations, so our first inequality is always going to be the same. The second, with the negative, we can make 6x minus 3 a negative, and that's less than or equal to a positive 15. So just like we did on the previous page, you can either change the solution to be a negative number and flip the sign, or you can put the negative with what's inside the absolute value. Again, either way should get you the same solution. Number 6, we're solving the absolute value of 6x minus 3 is greater than or equal to 15. Now notice greater than or equal to is going to be your or. So again, we're looking at our two cases. We have 6x minus 3 is greater than or equal to 15. And we have 6x minus 3. Again, we need to change the sign if we're change the symbol if we're changing the sign. So it'd be less than or equal to negative 15. Again, we're adding 3 to both sides. 6x is greater than or equal to 18. Divide by 6. X is greater than or equal to 3. Second inequality, solving the same as before. So 6x is less than or equal to negative 12. Again, we're dividing by 6. So x is less than or equal to negative 2. Again, graphing on the number line, closed circles, and we are going left with negative 2. We're going right with 3. So again, this is an or inequality. They're going in opposite directions. Again, one or the other solution needs to work, so this is correct. So x is greater than or equal to 3, and x is less than or equal to -2 are our two solutions. Now number 7, we are solving the absolute value of 3 minus x is greater than or equal to -5. Now if we look at the solution to these inequalities, inside the absolute value, if you're taking the absolute value of something, it's always going to be a positive number, a non-negative number. So if we have a non-negative number is greater than or equal to -5, we know that any number is going to work. So no matter what number we put in for x, it is always going to be greater than or equal to -5 because of the absolute value sign. So in this case, the solution is all real numbers. So we need to look for those special cases. Again, like I said before, make sure that you're looking at the problem, looking at the solutions, make sure that it's making sense. Absolute values can be used in word problems as well when we are looking at tolerances, which would be limits, distance, ranges, anything that has some kind of limit or ranges. We're going to use absolute value or inequalities. So number 8 says a manufacturer has a 0.6 ounce tolerance per bottle of ketchup, advertised as 16 ounces. Write and solve an absolute value inequality that describes acceptable volumes for 16 ounce bottles. So what happens in manufacturers is that if a bottle says that it's 16 ounces, it can be within 0.6 ounces and still be considered a 16 ounce bottle. So it could be 16.6 and they'll still call it 16 ounces. It can be 0.6 less than 16 and it can still be counted. So what we need to do is find what those acceptable values are using an inequality, absolute value inequality. So we know that our tolerance is 0.6 ounces. So we're going to take the actual weight, so that's the actual weight of the bottle of ketchup in this case. We are going to subtract the ideal weight, and that should be less than or equal to the tolerance. So now we just plug in the information that we know. So the actual weight, we don't know what the actual weight is. That's what we are trying to find, so we're going to call that x. We know that the ideal weight, or what the bottle should be, is 16 ounces. And we know that the tolerance, or the range, can be 0.6 ounces. So then we need to solve our absolute value equations, or inequalities, in order to find what the actual weight of the bottle could be. So we're going to look at our two cases. We have x minus 16 is less than or equal to 0.6, and then we have x minus 16 is greater than or equal to -0.6. And then we just solve these like we did before. So we're going to add 16 to both sides. So x is less than or equal to 16.6. For our second equation, again, we're adding 16 to both sides. So x is greater than or equal to 15.4. So again, if we look at this solution, this tells us that the ounces of the bottle have to be between 15.4 and 16.6 ounces in order to be considered a 16 ounce bottle of ketchup. So your 16 ounce bottle of ketchup might not be exactly 16 ounces. So again, absolute value and inequalities can be used in real life situations that deal with tolerances or limits.